Assalamualaikum and good day to everyone. My name is Wan Hazrila binti Wan Hassan from Wireless Communication Technology Group, School of Electrical Engineering, College of Engineering, UiTM Shah Alam, Selangor. My title is Performance Evaluation of IEEE 802.15.4 and IEEE 802.15.6 for the Wireless Body Area Network or wideband application. Background of study. A MAC protocol that complies with band rules and specification is necessary for the wideband application, and the design of the MAC protocol is challenging because of the characteristic of the wireless channel and the aim to get the low energy consumption. Therefore, in this study, we present the evaluations performance of two MAC protocol, which is the ZigBee MAC and baseline MAC in two conditions, which is the GTS on and GTS off. The GTS on is the condition where the CSMA-CA combined with the TDMA access mechanism, and GTS off is the MAC protocol with the CSMA-CA access mechanism. Introduction to wideband. The wideband is a YSN subcategory. The wideband is a communication network focused on the human body, and it has significant potential to improve wearable computing application and also e-healthcare technology. The wideband consists of several sensor nodes that provides continuous monitoring for certain period of time. The sensor nodes can be integrated in three different ways. First, on body sensors, where the sensor nodes are connected to the body. Second, in body sensor, where the sensor nodes implanted under the human skin. Third is off-body sensor, where the sensor nodes are kept a few millimeters away from the human body. The wideband can support real-time traffic such as data, voice and video to observe the vital organ functionalities. The sensor nodes attached to the human body are battery-powered device. The figure shows the communication architecture of the wideband communication, which can be divided into three separate levels. First, Tier 1 called intra-wideband communication. Second, Tier 2 inter-wideband communication. And third is Tier 3, which is beyond wideband communication. Overview of IEEE 802.15.4 superframe structure. This superframes operates in two modes of operation, which is first, beacon enable mode, and second, non-beacon enable mode. The superframe structure can be divided into active and inactive components. For data transmission, the active portion is further divided into 16 equal slots, which consists of beacon, a CAP and a CFP phase. The CFP will use the TDMA approach for data transmission. Meanwhile, for the CAP, it will use the CSMA-CA approach. The sensor nodes and coordinator will go into the sleep mode during the inactive portion after the CAP and CFP period. Overview of IEEE 802.15.6 superframe structure. This structure supports three physical layers, which is human body communications, ultra-wideband physical layer, and narrowband physical layer. It supports three modes of operation, which is the first one is beacon mode with beacon period superframe. Second, non-beacon mode with superframe, and third, non-beacon mode without the superframe. It consists of 9 different phases, which is EAP1 and EAP2, RAP1 and RAP2, CAP, and 2 beacon frames. EAP is designed for the highest priority data, and the RAP and CAP are reserved for regular patient data monitoring. Type 1 and Type 2 are offered for billing, uplink and downlink schedules. Concerning the heterogeneous and dynamic traffic loads, this superframe structure can be modified in terms of EAP and RAP phase. Simulation setting. This simulation is conducted by using the Castalia version 3.2, which is based on the Omnet 4.6 platform. Star topology is simulated by the wideband using 6 sensor nodes, which is 5 sensor nodes and 1 coordinator. Coordinator is node number 0, which is receive packets from all nodes. This simulation employs throughput tests for the application layer, which is built within the Omnet. Simulation result in terms of latency analysis. Most packets are detected in the GTS off configuration which with less than 100 millisecond of latency indicates that they are sent in the first MAC frame. Compared to GTS off, the CSMA-CA and TDMA combination, which is GTS on configuration, has no interference and more effective. The baseline MAC has less latency with the GTS than the ZigBee MAC. The sending packets for the channel without temporal variation produce more latency than the channel with temporal variation. MAC protocols based on TDMA and CSMA-CA mechanisms perform better than CSMA-CA only. Packet receive analysis. This section investigates the packet received in the GTS on and GTS off modes. When the GTS is turned on, the MAC protocol functions more effectively. The baseline MAC shows the same packet received in both GTS on and off. However, for the ZigBee MAC, it outperforms the baseline MAC when the GTS is turned on in temporal and in no temporal environments. Notice that the curve of ZigBee MAC during the GTS on with temporal increase as the data rate increase. This is because the GTS minimize the interference and make better use of the wireless channel. Additionally, the performance is improved if there is no temporal variation in the channel, because with temporal variation, connectivity between sender nodes and the base station is disturbed by the fading channel. Energy consumption analysis. Average energy consumption of the ZigBee MAC with the GTS on is 0.039 joule in both temporal and no temporal variation, and GTS off is 0.06 in both temporal and no temporal variation. Baseline MAC employs the same amount of energy consumption for both with and without the GTS. The power transmission do not influence the energy consumption. Therefore, the energy consumption depends on the state of the radio and the duty cycle. Baseline MAC and ZigBee MAC benefits from the superframe idle time where the sensor nodes are turned off. So it will save the significant energy and enable the coexistence of the different wireless network with the same transmission channel. Throughput analysis. The throughput will increase with the increasing of the packet rate. The ZigBee MAC protocol with the GTS on in temporal and no temporal channel give better throughput. It is mainly due to the use of the hybrid mechanism protocol, which provide the better network throughput performance. As a conclusion, comparative study of the existing MAC protocol, which is ZigBee MAC and baseline MAC, is presented. The performance of both protocols are compared using the Castalia 3.2 based on the Omnet platform. The analysis show that both MAC protocol perform better with the GTS on. Therefore, MAC protocol based on CSMA-CA and TDMA access mechanism will perform better than MAC protocol only based on the CSMA-CA access mechanism.